In this class, let us learn about interference, fringe width. Interference is demonstrated by the scientist Thomas Young, and the experiment is known as Young's double slit experiment. Light from a point source, is allowed to pass through a single slit to produce a narrow beam of light. And this narrow beam of light is allowed to pass through two slits, which are known as double slits. And the waves from the double slits superpose each other, giving rise to interference fringes on a screen. Alternate bright and dark bands are formed, with the central fringe being white. So S1 and S2 are the double slits, which are equidistant from the single slit. S1 is equal to S2. So the waves reach S1 and S2 at the same time. So there is no initial phase difference. The separation between the slits is small d, and the distance of the screen from the plane of the slits is capital D. O is the center of the screen, and P is a point at a distance y from the center. If you consider the point O, the waves from S1 and S2 travel equal distances to reach the point O. That is, S1O is equal to S2O. So there is no path difference or phase difference. So the intensity will be maximum. But if you consider the point P, the waves from S1 and S2 travel unequal distances to reach the point P. S2P is greater than S1P. So there is a path difference which is equal to S2P minus S1P. So let us calculate the path difference. In order to find the path difference, let us draw a normal S1N on the line S2P. So from the diagram it is clear that S1P is equal to NP. So S2P minus S1P will be equal to S2N. S2N is the path difference. S2P minus S1P. Theta is the angular position of the point P. So let us consider the triangle POQ, right angled triangle POQ. Tan theta is equal to opposite side y by adjacent side d, y by d. Let us consider the right angled triangle S1 and S2. This angle also is theta. Sin theta is equal to opposite side S2n by hypotenuse S1 S2, that is small d. S2n is the path difference x, so sin theta is equal to x by d. For small values of theta, sin theta approximately equal to tan theta. So we can write x by d is equal to y by capital D, or the path difference x is equal to y small d by capital D. Now let us apply the condition for constructive interference. For constructive interference, path difference x should be n lambda. We got the equation x is equal to y small d by capital D, or from this equation y is equal to x capital D by small d. So let us substitute for x n lambda. So y is equal to n lambda capital D by small d. If n is equal to 0, y is equal to 0. This is the position of central maximum. If n is equal to 1, y1 is equal to d lambda by small d, position of first bright band from the central maximum. For n equals to y2, which is equal to 2d lambda by small d, position of second bright band. Therefore, for the nth bright band, yn is equal to n d lambda by small d. Thus, we get the positions of maximum intensity. Now, let us apply the condition for destructive interference. For destructive interference, x is equal to 2n minus 1 lambda by 2. So, let us substitute in the equation for y equals x d by small d, yn is equal to 2n minus 1 d lambda by 2 small d, where n equals 1, 2, 3, etc. If n equals 1, y1 dash is equal to d lambda by 2d, position of first dark band from central maximum. For n equals 2, y2 dash is 3d lambda by 2d, position of second dark band. For nth dark band, yn is equal to 2n minus 1 d lambda by 2d. Now let us find the fringe width. It is a separation between two successive bright or dark bands. Width of a dark band is the separation between two consecutive bright bands. So beta is equal to, fringe width beta is equal to y2 minus y1. That is equal to 2d lambda by small d minus d lambda by small d is equal to d lambda by small d. Width of a bright band is the separation between two consecutive dark bands. Let us name it as beta dash, which is equal to y2 dash minus y1 dash. It is equal to 3 by 2 d lambda by small d minus 1 by 2 d lambda by small d, which is same as d lambda by small d. So width of a bright band is equal to width of a dark band. Now let us see the width of central maxima. Let us name it as beta 0. It is 2 y1 dash. It is the distance between first dark band on either side. That is 2 y1 dash. So 2 times d lambda by 2d, or d lambda by small d, which is same as beta and beta dash. So we can say in interference, all the fringes are of equal width. Now let us see the intensity pattern. At the center of the screen, we get maximum intensity, and for a phase difference pi, the intensity will be minimum because the interference is destructive interference. For a phase difference 2 pi, constructive interference occurs and the intensity becomes maximum. Distance between two consecutive maxima is the width of dark band, and the distance between two consecutive minima is the width of bright band, and the width of the central maximum is the distance between the first minima on either side, that is, it is 2 times y1. And the fringe width is same. All the fringes are of equal width, which is equal to d lambda by small d. But the intensity is given by a1 square plus 2a1 a2 cos phi plus a2 square. a1 and a2 are the amplitudes of the waves from the two slits, s1 and s2. And phi is the phase difference. For maximum intensity, cos phi should be 1. So maximum intensity is equal to a1 square plus 2a1 a2 plus a2 square, that is equal to a1 plus a2 the whole square. If a1 is equal to a2, then maximum intensity is 4 times a1 square, that is 4 times I0. I0 is the intensity of the light from one slit. For destructive interference, that is for minimum intensity, cos phi is minus 1. Then I will be equal to a1 square minus 2a1 a2 plus a2 square. That is I minimum is equal to a1 minus a2 the whole square. If a1 equals a2, I minimum will be 0. Now let us note the important points. Fringe width beta is equal to d lambda by small d. So fringe width is directly proportional to wavelength of light. But in a medium of refractive index n, wavelength is inversely proportional to refractive index. So the fringe width is inversely proportional to refractive index. Fringe width is directly proportional to distance between screen and the plane of the slits and inversely proportional to separation between the slits. For the interference fringes to be seen, S by S dash should be equal to S by S dash should be less than lambda by small d, where S is the size of the source slit and S dash is the distance of the source slit from the double slits. So this condition should be satisfied for the fringes to be seen. And if the source is a white light, then the central fringe will be white and the other fringes are colored fringes. Let us note some points about the intensity. Intensity is directly proportional to width of the slit. So the ratio of the width W1 by W2 will be equal to ratio of the intensity is I1 by I2. That is equal to A1 square by A2 square because intensity is the square of the amplitude. And maximum intensity is A1 plus A2 the whole square and minimum intensity is A1 minus A2 the whole square. And another important point is a path difference lambda corresponds to a phase difference 2 pi. Thank you.